So today we're going to be looking at a plugin that I've created called LightScope. So this project started as a visualizer for my live streams, and it's evolved into a tool that I've been using quite a lot. And I found that in some circumstances it's helped me with my mixing. So I thought I'd put it out there and see if it helps you with your mixing too. Now there's two main parts to this project. One of them is this module here. This is based on Juice, and I'll put a link to the XDLightScope GitHub repository so that you can see it for yourself. And here is in a submodule a link to the other part of this project, which is the DSP library that I'm using. And I'll put a link to the DSP library GitHub as well, so you can check that out. Let's have a look at the code. So this is the producer file that you'll find at the root directory of the repository. There's one exporter set up for Xcode. I haven't tested this on Windows yet. If you're keen, download it. You'll see here that I haven't downloaded Juice 7.0.10 yet because it doesn't compile in Juice 7.0.10, so I'm not going to update it. It compiles fine in Juice 7.0.9. I'm waiting for 7.0.11. Anyway, so we click the save button and open up in Xcode. In my DSP library I have some classes for doing circular buffers, really handy for delay lines and things like that. And I have a container class for the biquad filter coefficients, and I've got a container class for a biquad filter kernel. And here they are declared for two low-pass filters. Here is a mutex because the circular buffer in my DSP library is not thread safe, so I have a mutex there to protect it. And then I've got two static crossover points. So the low crossover point, which is this one, is set at 600 Hertz. So anything below 600 Hertz will appear red in the scope. And the high crossover point is set at 4 kilohertz. Anything that appears above that will be blue, and anything between those values will be green. These values, I didn't just pluck them out of thin air. I actually adapted this code from another open source project called Mix, which is open source DJ software. Some of this code is based on or derived from that, and that high-low crossover points are, I found those values when I was studying the Mix code. And I also have a buffer. This buffer is for mixing the stereo down into mono. All of the color processing is done in mono. Now, for the most part, this is a stock Juice plugin template. I've only modified a few bits of code to interface my library. Here we sum the signals to mono, and then here, where the mutex is locked, we run a filter over the mono, and here we tap the left and right audio into individual circular buffers. And here is the filter section. It takes the mono input, runs the low pass filter, and then subtracts the difference to get the high pass. So if you get a full signal, it subtracts the low pass signal, you're left with the opposite, the high pass signal, and then that is filtered again with a second low pass to create the mid-range data here, and then that's subtracted from the full mix to make the high pass for the treble, the blue color. All right, so let's check out the scope, the actual class which does the graphics. It's a subclass of the Juice component class. So I'll take you on a quick tour now of the XD DSP library. There's one C++ file. If you do use the library, make sure you compile and link the C++ file. Today we looked at this one, circular buffer. So circular buffer classes, they encapsulate all the code necessary for doing circular buffers, which are always really handy to have when you're doing digital signal processing. The other code that we were working with is this one. So in here we have the biquad filter coefficients class, which is the one I showed you earlier, where the parameters are stored. There's also a little bit of code here for calculating the filter response. Here's the biquad filter kernel class. So going back to the plain header file, you can see there's a lot of different components. Another really important one is this parameters class. So one thing that really ticked me off using a lot of other DSP libraries is there's no easy way to just keep track of things like the sample rate, the size of the buffer, and other parameters that you might want to keep track of in different parts of your code. So I created a class called parameters. Here in my plugin processor, I've got a parameters object here, and when we construct the filter coefficients objects, we pass it the parameters object. But essentially what this allows you to do, if we go back to now, if you're familiar with Juice, you'll know about the prepare to play method. This method gets called by Juice when the plugin is initialized and it's connected to the DAW, and it's passed the sample rate and the block size. I simply set the parameters in the parameters object, sample rate, buffer size, simple as that. And then those parameter settings get passed around throughout the entire component matrix, which in this case is just 2 filters. When you have a really complicated DSP network, this sort of thing comes in handy to just have one setting to change the sample rate for the entire network. And then that connects in one spot. Load up Ableton Live. Okay, so I've got a blank live session open. Cut out all the crap. Let's load a percussion loop. It doesn't matter what it is. And let's put the visualizer on there. I'm going to load the audio unit version. And observe when I hit play. So you might see straight away that this sort of emulates the waveform display that you'll see in a lot of popular DJ software, where the bass is in red, the mids are in green, and the trebles are in blue. And I can get Ableton's built-in EQ3, put it before, and show you there. I take out all of the mids, and you're left with purples and reds. Take out all the highs, it's just reds. Just the mids, it's greens, though the cutoff points aren't quite the same. And then the highs are just blue. Pretty simple idea. Alright, so now let me load in a sneaky preview of my next release. It's called Hold. Very cool. You can see the track's got a colour, and what I've done is I've looked at a lot of different reference tracks, a lot of tracks that I like the sound of, and I've looked at them through this scope. And then I've compared my tracks, what colour they look like. You get the idea. And this has helped me a lot, not just with tonal balance, but when it comes to mixing individual elements. Let me load the project file for this track. Playing the groove. Of course, the volume levels are a lot lower because this is a mix, it's not a master. I've got all of my channels bussed, and then I can put the light scope over the bus. The kick and bass bus is the best example for this. And you can see here, the bass has a very sort of orange color because there's a lot more mid-range energy in this bass. And then when I go to the big climax, you see the bass there, there's a lot of that low mid-energy is taken out for this part. Leave lots of room for the pads and for the musical elements. If I put a loop here and solo, and I've got my bus processing here, I can see the difference between bus processing off and bus processing on. And you can see how it's affecting the balance of all the elements in my mix. And because of the different colors, you can tell straight away, just by looking at it, which element is in that part of the waveform. So as you can see here, before the bus processing, the bass is quite uneven. There's lots of ups and downs, but with bus processing, it gets nicely evened out. So I hope you've enjoyed my quick and possibly boring tour around my XDLightScope plugin. I'm going to go into a bit more detail into it in further videos in the future, showing you how I use it for mixing, showing you how to download the GitHub repository and compile it on your machine, and we'll go into depth with a couple of other things that I've created with this library as well. Looking forward to you joining me in the future, and if you're interested, yes, hit the like, hit the subscribe, hit the notification button, and yeah, I'll see you in the next one.